Welcome to the Copperfield Electric Podcast. Imagine this scenario for a second. A massive storm rolls through, or, maybe just a local grid failure, and it completely knocks out your power.
Right, which seems to be happening more and more these days.
Yeah, exactly.
Yeah.
But you are prepared, right?
Mhm.
You fire up that brand new, really powerful DIY generator you just bought. You wire it directly into your home system, the lights flicker back on, and you basically feel like a genius.
Well, until you realize what you actually just did.
Right. Because what you probably don't realize is that in that exact moment, you have just sent thousands of lethal volts of invisible electricity straight out of your house.
Yeah, right into the hands of a utility worker who
Yeah.
might be, 3 streets over, just trying to fix the very outage you are hiding from.
It is a terrifying scenario.
It really is. It's chilling, actually. But it plays out far too often. I mean, when we try to force power back into a home without respecting the actual physics of how it gets there,
Right.
we aren't just risking our own appliances. We are quite literally creating a deadly hazard for the surrounding community.
Which is exactly why we are stepping out of the dark today for this custom-tailored deep dive. We are going to completely demystify backup home power for you.
Yeah, it's about time we dig into this.
It really is.
Yeah.
So to do this, we are pulling from a really insightful article. It's dated May 1st, 2026 by Renee Hernandez, and it's titled, "What is a Transfer Switch for Generators?"
A great piece. Really breaks down the hardware.
It does. And to ground all this theory in reality, we are layering in the extensive background materials from Copperfield Electric. They're a top-tier, family-owned electrical business servicing Southern California.
It's honestly the ideal combination of sources for this topic. I mean, we get the mechanical breakdown of the hardware from Hernandez,
Right.
paired with the practical, on-the-ground reality of how these backup systems are actually engineered, permitted, and, maintained in modern homes today.
So here is our mission for this deep dive. By the time we wrap up today, you're going to understand exactly how emergency power safely connects to your home, like down to the actual mechanisms.
We are getting into the weeds.
We are. We're also going to explore why DIY generator setups are an absolute recipe for disaster. And finally, who you should actually be calling when you need a professional to handle this kind of high-voltage physics.
It's a critical roadmap for anyone looking into this. Because, installing a backup generator isn't simply about buying a large engine, pouring in some gas, and just plugging it into the wall.
If only it were that simple.
Right. But no, there is an incredibly sophisticated gatekeeper involved.
Yes, the gatekeeper. Before we even talk about the generator itself, we really have to understand this critical middleman that makes the whole system possible.
The transfer switch.
Exactly. This is the device Hernandez really focuses on in the article. Okay, let's unpack this. A transfer switch is essentially a piece of hardware mounted near your electrical panel.
Right next to it, usually.
Yeah, and it manages the flow of electricity between two entirely distinct, totally opposing power sources. On one side, you have your utility grid, so the normal power coming from the street.
Right.
On the other side, you have your backup generator.
And it operates with a very specific, totally non-negotiable logic. When an outage occurs, the transfer switch steps in. Its very first job, before it does literally anything else, is to physically disconnect your home from the utility grid.
It cuts you off from the street entirely.
Completely severs it. Only after that connection is completely broken does it open the gate to let the power from your generator actually flow into your home's circuit panel.
Okay, got it.
And when the utility power finally comes back on, the switch reverses the whole process. It cuts off the generator entirely and then, only then, reconnects you to the grid.
I was trying to picture how to explain this, and I keep coming back to this idea of really strict bouncer and an exclusive club.
Oh, I like that.
Right, so the club is your home's electrical panel. The bouncer is the transfer switch. And the bouncer's absolute #1 rule is that only one VIP guest is allowed inside the club at a time.
So no mixing.
Exactly. The utility grid's in there partying, but suddenly passes out, that's your power outage. The bouncer immediately kicks the grid out the back door, locks it, and only then lets the backup generator in through the front.
That paints a very clear picture, actually.
And when the grid wakes up and wants back in, the bouncer makes the generator leave first.
What's fascinating here is the absolute mechanical precision of this process. I mean, in the industry, this is known as a break-before-make mechanism.
Break before make. I want to pause right there, actually, because break before make sounds like a catchy marketing slogan.
Yeah.
Why is it mechanically necessary?
That's a good point.
Like, why can't the switch just smoothly blend the two power sources together? Like adjusting the hot and cold dials on a shower until the temperature is just right. Why the hard physical disconnect?
Well, that is a great question, and it all comes down to the nature of alternating current, AC power. The electricity flowing through your wires, it isn't a flat line.
Right, it's a wave.
Exactly. It's a wave that pulses up and down 60 times a second. So if you try to blend the utility grid and your generator without a hard disconnect, those two waves are not going to be perfectly synchronized.
You'd be totally out of rhythm.
Totally. The peaks and valleys of the grid's electrical wave will crash directly into the peaks and valleys of your generator's wave.
Oh, wow. So it's less like mixing hot and cold water and more like two massive ocean waves colliding perfectly head-on.
Precisely. That uncoordinated clash of voltages would cause a massive electrical spike. I mean, it would instantly fry your sensitive electronics, melt the insulation on your wiring,
Which is terrifying.
and very likely start an electrical fire inside your walls. So to prevent that, you can think of the transfer switch like a literal railroad track switch.
Oh, okay.
The physical steel tracks have to detach, swing over, and align with a completely new path. It is physically impossible for the train to be on both sets of tracks at the exact same time.
The transfer switch enforces that physical boundary.
Right. It forces the issue.
Which brings us to a really dark corner of this topic, referencing back to the scenario we opened the deep dive with. Because now that we know what this mechanical switch does and why it has to exist,
Yeah.
we have to address what happens when people try to operate a backup system without one. The Hernandez article points out that some homeowners honestly believe they could just bypass these rules.
Oh, they do?
They try to connect a generator directly into an appliance outlet or right into the panel.
It is a terrifyingly common practice, often fueled by, internet forums and bad advice. And as the sources clearly state, it is not just wildly unsafe, it violates electrical codes and is often highly illegal.
But I want to play devil's advocate for a second here,
Yep.
because I know what a lot of DIY-minded folks might be thinking right now.
Let's hear it.
Let's say the power goes out. If I just walk down to my garage, manually flip my home's main breaker to the off position, isn't that essentially doing the same thing as the transfer switch? I'm physically disconnecting my house from the street grid.
In theory, yes.
So why do I need to pay for a separate piece of hardware to do it for me?
This raises an important question, and it is the exact trap that a lot of really well-meaning homeowners fall into. The short answer is human error.
Ah, of course.
When you rely on a manual workaround, you are relying on a human being who is likely stressed, holding a flashlight in their mouth, fumbling in the dark during a sudden outage, to perfectly execute a flawless sequence of steps every single time.
Right. And if you forget to flip that main breaker, or, if a spouse or a teenager goes down to the panel 2 days later and accidentally flips it back on while the generator's running, what happens then?
Then you immediately initiate a phenomenon called backfeeding.
Backfeeding.
Yeah.
Just the word alone sounds ominous.
It is the invisible threat of backup power. Backfeeding happens when the power from your generator flows backward out of your house, passes through your electrical meter, and surges out into the dead utility lines on your street.
So wait, instead of powering your refrigerator, your little portable generator is suddenly trying to power the entire neighborhood grid.
Exactly, which, first of all, will instantly overwhelm and destroy your generator.
Make sense?
But honestly, the destruction of your equipment is the absolute least of your worries. To understand the real danger here, we have to talk about the utility transformers on your street. You've seen them, right? Those big gray cylinders on the telephone poles, or maybe the green metal boxes sitting on the ground in your neighborhood.
Right, those are the things that sometimes explode with a really loud bang during a lightning storm.
Yes, exactly. Normally, their job is to take massive high voltage coming from the power plant, often 7,000 volts or more, and step it down to a safe 120 or 240 volts that your home can actually use.
Okay, that makes sense. High voltage from the street gets stepped down for the house.
But here is the critical physics lesson. Transformers do not have a brain.
What do you mean?
They are completely passive devices made of interacting copper coils. They don't know in from out. So if your generator backfeeds 240 volts of electricity backward into the outdoor of that transformer, the physics blindly run in reverse. The transformer multiplies your generator's power, stepping it up to 7,000 volts or more.
Oh, wow. Wait, so you are basically weaponizing the power lines on your street?
You are, and right at that exact moment, somewhere down the line, A utility worker has been dispatched to fix the outage in the freezing rain. They have tested the line upstream, they believe it is dead, and they touch it.
Oh my gosh.
They are instantly hit with lethal, high-voltage electricity generated by the backyard setup you thought was harmless. Backfeeding creates a deadly, totally unpreventable hazard for the very people trying to restore your power.
That puts an entirely different perspective on it.
It really does. That is why a transfer switch is not a suggestion. It's not some upsell from an electrician, and it's not just a convenience. It is a mandatory, life-saving barrier.
It's a fundamental civic responsibility at that point.
Yeah.
It's not just about protecting your television.
Yeah.
Okay, so we firmly established that a proper transfer switch is an absolute requirement.
Yes.
The next phase the article explores is how to choose the right configuration. Because, you don't just buy a generic box off the shelf at the hardware store. You actually tailor this hardware to your specific home.
That's correct. There isn't a one-size-fits-all solution here at all. You generally have two main categories to choose from: manual systems and automatic system.
Let's break down how those actually function.
Mm-hmm.
A manual switching system is pretty much what it sounds like, right?
Yep.
It requires active user operation.
Exactly.
So if power goes out, your house goes dark. You have to walk to the panel, physically throw the large transfer switch lever to disconnect the grid, and then go outside to start your generator.
Right. You're the one pulling the literal levers. The benefits here are a lower upfront cost, and honestly, it's highly reliable because it's mechanically very simple.
That makes sense. It works perfectly fine if you live in an area that only experiences short, infrequent outages.
But then you have the automatic transfer switch, which is really the gold standard for modern homes. When an outage hits, you don't do anything. The system handles it all.
I am really curious about the mechanism here, though. How does an inanimate box on the wall actually know the power grid went down?
It uses active voltage monitoring. Inside the automatic transfer switch, there is a sensing circuit that is constantly measuring the voltage coming from the utility line 24 hours a day.
Just constantly watching it.
Yep. And the millisecond that voltage drops below a safe threshold, meaning the grid just failed, the switch triggers a sequence. It sends a low voltage signal to your standby generator telling it to start its engine.
Okay.
Once the switch confirms the generator is producing stable power, it activates these massive magnetic contactors. You can actually hear a loud thunk when it happens.
I've heard that.
Yeah. Those contactors automatically disconnect the dead grid and snap the generator's power lines into place.
That is incredible. So usually within, 10 to 20 seconds, the lights just magically come back on. You don't have to lift a finger.
Exactly. Which is ideal if you are out of town when the power goes out and you want your security system to stay active, or, if you just want absolutely no major interruption to your daily life.
Right. But regardless of whether you choose a manual lever or that high-tech automatic magnetic system, the transfer switch does something else that I found really clever. It allows you to prioritize your circuits.
Oh, this is a crucial element of system design.
Here's where it gets really interesting. Think of your backup generator like a lifeboat for your house.
Mm-hmm.
If the cruise ship is sinking, meaning the grid is totally down, you cannot fit the entire cruise ship into the lifeboat.
Right, it's just not big enough.
If you fire up your generator and try to run your whole house at the exact same time, every television, the electric dryer, the pool pump, the microwave, your lifeboat is going to capsize. The generator will stall out and shut down.
That is a very accurate analogy. The transfer switch essentially acts as the captain of that lifeboat, determining well in advance who gets a seat and who gets left behind.
Exactly. When the electrician installs the switch, you actually get to pre-select which circuits are wired into it as essential. The article lists the big ones you'd expect, right? Refrigeration, save hundreds of dollars of food.
Just essential.
Basic lighting systems so you aren't wandering in the dark. HVAC equipment if you're dealing with extreme winter weather or summer heat. Medical devices, which can be literally life-saving. And of course, your internet router so you can actually communicate with the outside world.
And if we connect this to the bigger picture, prioritizing circuits is entirely about the physics of load management. Generators have strict limits.
Right.
They have what are called running watts, the steady power they can provide continuously, and then surge watts.
Surge watts, meaning like the extra burst of power to get something started.
Right. Think about your refrigerator. When the compressor kicks on to cool the inside, it requires a massive temporary spike in electricity, often 2 to 3 times its normal running power, just for a few seconds.
Oh, wow. That's a huge spike.
It is. If your generator is already maxed out running your lights and your TV, and then the fridge compressor tries to surge, the generator will overload.
And shut down.
Exactly. By hardwiring only your pre-selected essential circuits through the transfer switch, you mathematically prevent the generator from ever exceeding its capacity. You are protecting the machine from failing at the exact moment you need it the most.
It is all about giving yourself a manageable, tailored power footprint. But of course, even the most perfectly tailored lifeboat is completely useless if the engine is rusted or the hull has a hole in it when the storm actually hits.
True.
And that brings us to the ongoing reality covered in our sources, upgrades and upkeep. Because you cannot just pay for this equipment, mount it to the wall, and forget it exists.
It is a dynamic mechanical system, and just like a car or, an HVAC unit, it requires active, scheduled maintenance. The Hernandez article outlines a really clear schedule to ensure this emergency system is ready to perform year-round.
Right. For the generator itself, they recommend running tests every single month. You need to actually fire it up and let it run under a load.
You have to check the fuel levels, too.
Yeah.
And honestly, more importantly, replace old fuel. I think a lot of people forget that gasoline degrades over time.
It really does. It turns into this thick varnish that will completely ruin a carburetor.
It's a nightmare to clean out. You also need to clean the air filters, check the oil, and do a simple visual inspection of the wiring, to make sure rodents haven't been chewing on it.
Always a fun discovery. But equally important is actively monitoring the transfer switch itself and your main circuit panel. You need to look for warning signs.
Right. Are the breakers inside the panel tripping frequently during normal use? Is the power not switching over smoothly when you perform that monthly test? Does the equipment simply look outdated with rust or scorch marks?
Scorch marks are never a good sign.
Never! These are indicators that your system is actively struggling. The source strongly recommends an annual inspection by a licensed electrician to catch these hidden high-voltage problems before they become catastrophic failures.
This brings up a really interesting scenario for you. What does all this mean for the listener who, say, just completely renovated their kitchen and added a massive electric induction stove?
Oh, yeah.
Or maybe they finally installed that central AC unit before the summer heat wave. Do they need to rethink their whole backup power system?
They absolutely have to rethink it. And this is perhaps the most common, dangerous oversight in home electrical systems today.
Really?
Yes. Modern homes draw vastly more power than older ones. When you add high-draw appliances, an induction stove, a new HVAC system, or let's say you build an ADU, an accessory dwelling unit in your backyard.
Oh, that is huge right now, especially in Southern California. Everyone is converting their garages into ADUs.
Precisely. Or they are buying an electric vehicle and installing a level 2 charger right in the garage. When you do that, you fundamentally change the electrical footprint of your property.
That makes total sense.
The circuit panel, the wiring, the generator, and the transfer switch were all mathematically sized for the old normal. With an ADU and an EV charger, your demand skyrockets. They might absolutely need an upgrade to handle the new normal safely.
And if you don't upgrade,
If you try to push a massive modern electrical load through an outdated, underrated transfer switch or main panel, the copper components will literally overheat.
wow.
You risk melting the hardware, destroying the equipment, or creating a severe smoldering fire hazard right inside your walls.
Which means adapting to modern power needs isn't a weekend DIY project you can just learn from an online video.
Definitely not.
You are dealing with high voltage physics that require strict code compliance, city permits, and absolute precision. That naturally begs the question, who exactly do you trust to get this done?
Right.
This is where the background materials for Copperfield Electric become incredibly relevant, especially if you are listening from Southern California.
Yes, because as the article explicitly states, incorrect installation of these systems leads to fire hazards, permanent equipment damage, massive safety risks, and immediate code violations.
So professional installation is non-negotiable.
100%.
And if you're sitting in a home in Irvine or Costa Mesa, wondering if your 20-year-old panel can handle a new standby generator, you don't want to call a salesman. You want an expert.
Exactly.
Copperfield Electric, operating under license number 1094740, really stands out here. They're a top-tier, family-owned business servicing Orange County and the wider Southern California area.
They have a great reputation.
They really do. We are talking about Anaheim, Santa Ana, Newport Beach, Huntington Beach, Mission Viejo. They cover that whole region, and they handle everything we've been discussing today. Home generator installations, complex electrical panel upgrades, EV charger setups, and all the new construction wiring for those ADUs we just talked about.
What really stands out to me about their company profile is their strict philosophy of what they call honest troubleshooting.
I found that fascinating too. It seems pretty rare in the service industry.
It is incredibly rare, and it's paramount in the electrical field. They explicitly state that they will only diagnose a problem if it truly exists.
Imagine that.
Right. In my experience, the hallmark of true expertise isn't just knowing how to swap out an expensive piece of hardware. It is the ability to accurately diagnose the root cause of an electrical failure.
Because it's so complex.
It is. There are plenty of technicians out there who might try to sell you a completely new $5,000 panel when all you actually needed was a specific degraded circuit breaker repaired.
Right.
Copperfield Electric's focus on accurate, honest troubleshooting saves the customer significant money in the long run and honestly builds a genuine foundation of trust.
And building on that trust is their reality-based availability. They are a true 24-hour electrician. They offer 247 emergency support.
Which is crucial.
Let's be real for a second. Electrical emergencies, blown panels, and massive power grid failures almost never happen conveniently at 10 a.m. on a Tuesday when everyone is in the office.
Nope. They happen at 2 a.m. on a Sunday during a torrential rainstorm.
Exactly. Knowing you have a seasoned, background-checked, licensed, and fully insured team that offers actual after-hours service is a massive safety net.
It provides immense peace of mind. They also offer a 100% satisfaction guarantee, which demonstrates total confidence in the quality of their engineering.
Absolutely.
Whether it is a sudden, terrifying power outage where your automatic transfer switch just isn't engaging properly, or a planned, complex upgrade like adding a heavy-duty sub-panel for an EV charger, having a reliable local gatekeeper is just as important as having the right equipment on the wall.
It really is. So what does this all mean? We have covered a lot of technical ground today, from colliding AC waves to exploding transformers.
You really went deep.
We did. Let's bring it all back together. If you take away anything from this deep dive, it should be this. A transfer switch is never just an optional accessory for your backup generator.
Never.
It is the ultimate, non-negotiable safeguard for your home, your expensive appliances, and the brave utility workers out on the street trying to get the lights back on.
Well said.
It is about understanding your exact power priorities, making sure your electrical lifeboat is sized correctly for your modern needs, and most importantly, relying on trusted, honest, local experts like Copperfield Electric to handle the heavy, high-voltage lifting.
And as we wrap up our analysis today, I would like to leave you with a thought to mull over, kind of building on the trajectory of everything we've discussed.
I'd love to hear it.
As our society becomes increasingly reliant on uninterrupted power, think about the massive permanent shift toward full-time remote work, the daily integration of EV charging into our garages, and the growing reliance on critical at-home medical devices. The stakes of losing power are undeniably higher than they were 20 years ago.
They really are.
It makes me wonder, how soon will automatic transfer switches shift from being viewed as a backup luxury for the wealthy to a legally mandated standard safety feature built into the electrical panel of every single new home constructed in America?
That is a fascinating question to end on. Because at the end of the day, we all want the magic to keep working. We want to flip that plastic switch on the wall and know with absolute certainty the light is going to come on. But when the magic fails and the grid goes dark, you need a gatekeeper you can trust and an expert who can make sure the right train is on the right track. Thank you for joining us on this deep dive into the invisible world of backup power. Stay safe, stay powered, and we will catch you next time.